Hey everybody and welcome. Today we're going to be looking at quest number 6, problem number 13. So it's this inclined plane problem right here that we've got. So we've got a block at rest on the incline shown below. We're given the coefficients of static and kinetic friction, 0.73 and 0.62 respectively. And we know gravity, the acceleration due to gravity is 9.8 meters per second squared. That's standard. We're asked to find what's the frictional force acting on this mass. Okay, so as always, we're going to draw a free body diagram. So let's go ahead and do that first. We're going to draw our free body diagram. I don't like that color. I'm just color darker. So we've got this free body diagram right here. Okay, and we have a bunch of forces acting on this. So let's start to look at them. We've got our weight force that acts down like that. We've got our normal force. And we have our frictional force going this way, which I'm going to denote as F sub FR, F for friction. Okay, so what do we know? We know we can take this gravitational force and break it up into its components. So this is equal to mg. We know that to be true. That's just an equation that we always know. And what we can do is we can say, okay, let's look at this. That's going to be mg times the cosine of theta. And this is going to be mg times the sine of theta. That's something we talked about when we're looking at decomposition of vectors on inclined planes. And we're going to use this as our theta for those. It's the same angle. You can look at it that way. So we have now all of our forces are either parallel or perpendicular to the plane. Remember that this direction, that's our parallel direction, up and down the ramp, and then this is our perpendicular direction. Oh, into and away from the ramp, that's perpendicular, just some notation stuff. So we're given that this block is at rest. So what that tells us is that if we're looking at Newton's first law, the law of inertia, that tells us that the forces are balanced, or more specifically, that the net force in the parallel direction is equal to 0. So what does that mean? So if we call up the ramp as positive, that means that we have the force of friction minus the component of the weight force that's parallel, which is mg times the sine of theta. That must equal 0. So in this case, that means that the frictional force is equal to mg sine theta, which is equal to 39 kilograms times 9.8 meters per second squared times the sine of, in this case, 32 degrees. And we get at the end that our frictional force is equal to, let me do my math, 39 times 9.8 times the sine of 32 degrees. Make sure you're in degree mode for this. I get 202.5 newtons. And there you've got it. That's how you do this type of problem. You're going to have different numbers, obviously, so make sure you go through with your own numbers, but hopefully this kind of helps you think through exactly what the problem's telling you. Sweet. See y'all later. Good luck.